Bond polarity refers to the distribution of electron density between atoms in a chemical bond. It determines the degree to which electrons are shared between atoms and whether the bond behaves as polar or nonpolar. In a polar bond, electrons are unequally shared between atoms, leading to partial charges on the atoms involved. In a nonpolar bond, electrons are equally shared between atoms, resulting in no net dipole moment. Here's how to determine bond polarity in molecules. Identify the electronegativity difference. Compare the electronegativities of the atoms involved in the bond. Electronegativity is the tendency of an atom to attract electrons in a chemical bond. Use the periodic table to determine the electronegativity values of the atoms. The greater the electronegativity difference between two atoms, the more polar the bond. Determine the type of bond. If the electronegativity difference between the two atoms is small, typically less than 0.5, the bond is nonpolar covalent, meaning that electrons are shared equally between the atoms. If the electronegativity difference is moderate, between 0.5 and 1.9, the bond is polar covalent, indicating unequal sharing of electrons and the presence of partial charges on the atoms. If the electronegativity difference is large, typically greater than 1.9, the bond is ionic, with one atom fully donating electrons to the other, resulting in the formation of ions. Consider molecular geometry. In molecules with multiple bonds or multiple polar bonds, consider the overall molecular geometry and the spatial arrangement of polar bonds. If the polar bonds are symmetrically arranged and cancel each other out, the molecule may be nonpolar overall despite the presence of polar bonds. If the polar bonds are asymmetrically arranged, the molecule may be polar overall. Assess dipole moments. Calculate the dipole moments of individual bonds based on the electronegativity difference and bond length. A dipole moment is a measure of the polarity of a bond and is expressed in debye units, d. The direction of the dipole moment points from the less electronegative atom, partial positive charge, to the more electronegative atom, partial negative charge. Add up the individual dipole moments to determine the overall dipole moment of the molecule. Determine overall molecular polarity. Based on the individual bond polarities and molecular geometry, determine whether the molecule is polar or nonpolar overall. If the molecule has a net dipole moment, it is polar. If the molecule has no net dipole moment, it is nonpolar. By following these steps, you can determine bond polarity in molecules and assess the overall polarity of molecular compounds based on their chemical structure and composition. Understanding bond polarity is essential for predicting the physical and chemical properties of molecules and their interactions in various chemical reactions.